Let's now look at the graph of functions that are inverses of each other. In blue here, I've drawn this function, f of x, and its inverse function, f with that little -1 up in the air of x. The graphs of the function and its inverse function are related to each other in the following way. If the point AB, that's x comma y, that's the point on f of x, is present, then its point on the inverse will be BA. I'm telling you that the domain and the range switch. That's all x's and all y's. So here's an example of that. The point xy becomes the point yx, or AB becomes BA. I switch the domain and range, which means I switch all x's and all y's. The x coordinate was A, it becomes the y coordinate. The y coordinate was B, it becomes the x coordinate. This means that the graph of the function and its inverse are reflections of each other across this diagonal line, y equals x. Remember, from algebra, this is y equals 1 over 1x plus 0, where 0 is our y-intercept here, right at the origin, and its slope is up 1 over 1. Earlier, we showed that the functions 2x cubed minus 1 for f of x and g of x was the cube root of x plus 1 divided by 2. We showed algebraically that they were inverses. What happens when we graph them? Well, you can see that they are mirror images across this line y equals x. Note, if the point 0, -1 is on f of x, how did I find that? I just put a 0 in for x. 0 cubed times 2 is 0 minus 1 is -1. Then it's flip the points. Then -1, 0 will be on the graph of g of x if they're inverses. Also note, if the graphs meet each other, they will meet along this line, the mirror image line, y equals x. If they intersect each other, they'll be on that y equals x line. Now, a y equals x line means that the x coordinate will equal the y coordinate. I don't know what this point is, but it could be 4, 4, or 3, 3, or 2, 2, or something like that. Wouldn't be hard to figure out what that point is. If I'm asked to verify that f of x equals x minus 5 divided by 2 and g of x equals 2x plus 5 are inverses of each other numerically, well, I can make a good argument using numbers. If I'm looking at x and y, or x and f of x for this function, notice I chose values that gave me whole numbers or integers as answers. Integers, not whole numbers, sorry. -3 minus 5 is -8 over 2 is -4. If I plug in a -1 minus 5 is -6 divided by 2 is -3. 1 minus 5 is -4 divided by 2 is -2. 3 minus 5 is -2 divided by 2 is -1. Now, if I take those outputs, remember that little cloud drawing we drew? The outputs from f of x become the inputs of g of x if they're inverses. -4 times 2 is -8 plus 5 is -3. The x's and the y's have switched. If I take the output here and make it my input or my domain for g of x, -3 times 2 is -6 plus 5 is -1. Look, the x and y coordinates have just switched. -2 is the output from f of x. -2 times 2 is -4 plus 5 is 1. You can see the input and the output, the x and y have switched. -1 was our output, uses the input. -1 times 2 is -2 plus 5 is 3. So you can see every xy point I chose became yx. And so these are inverses of each other to the best of my knowledge based on the numbers I chose.